All right, so with this demo, we're going to see some of these best practices in action. The first thing we're going to do is we're going to set up a new cluster. Now this is something we did in depth in that other course, so I'm not going to go through all the details here, and likely you've already set up one yourself. I'm going to give it a highly original name called load sample, and then a database name, and then I'll just burn through all these other details, adding a username and a password. Now I want you to note two things here. I'm using a DC2 large node type, and it is going to be a multi-node cluster. The number of nodes that I'm going to provision is 4. On the last screen here, I'll accept pretty much all the defaults. The only thing I'm going to modify is I will add an IAM role that I already have set up so that this cluster can talk to my local S3 storage. Again, all the ins and outs of setting up S3 and all these rights and properties going back and forth between the S3 storage and your cluster are covered in that first course if you need a refresher. So I won't make you watch while this thing provisions. It'll take a handful of minutes. So I'm going to fast forward into the future here, and welcome to the future. As you can see, we have a healthy cluster, 4 nodes that are DC2 large. And now let's set up some sample data to load. First, however, we're going to need a table to load it into. So I'm pasting in a create statement. This table is actually a table provided by AWS. It's in some of their sample walkthroughs and data that's available right on their website. Now I'm not using one of the Abacus widgets tables because frankly Amazon makes these to demonstrate some of the very things that I want to demonstrate, as well as they have a ton of sample data that I can use, so it's a whole lot easier not to have to create that data. In fact, we're going to load about 600 million rows because I really want to show the difference between these approaches. Now I have my own local S3 bucket called Redshift load queue, and in that I've got 8 files. Now these are compressed using gzip compression, and individually they're all 3.1 gigabytes. This represents that roughly 600 million rows of data that I want to load into that table. You can get that sample data from this public S3 bucket here. This bucket is provided by Amazon. I'm showing that to you here, and there's actually some other sample data in there as well. And Amazon actually has a whole bunch of sample data. This is just a sliver of it. I use this one because this is the largest set. I wanted to work with a lot of data. And side note, you actually could load just from that public S3 bucket. I copied it into my own local S3 bucket because I wanted to demonstrate a few different approaches to the same data, and I wanted all things to be the same. Also, I wanted to combine this data in a later demo. So I needed to do that all locally in my own S3 bucket. So we've got a simple copy statement here. The important details are, first, I'm specifying the line order 000. That's actually a prefix, so it's going to get all 8 of those files because they share that prefix. I specify the IAM role, and then note the gzip clause. So it knows that this is compressed data. So remember, I have a cluster made up of 4 nodes, and I'm copying in 8 files. So that is a multiple of my nodes. Fast forward into the future, and we've loaded over 600 million total records in right about 9 minutes. So honestly, that's really fast. I mean, that's 2/3 of a billion rows of data that we loaded in 9 minutes. So I want to go 2 directions now with this demo. I'm going to do it again, but I'm going to bump up the number of nodes in my cluster from 4 up to 8. That way, I can have each file loading into a node all simultaneously. So that is going to be roughly twice the parallelism as prior. And then once we do that, I'll rerun the demo, but this time I'll take it all down to a single file, uncompressed.